there, there is money here, and today I have decided to make a small random video actually on certain activities that we can do to make the student probably enjoy the electrostatics and like basic properties, to understand the basic properties of charges. As you already know, charges are basically like nothing but the fundamental property of matter which makes them to experience force of attraction or repulsion. Oh my god, like when I say force of attraction or repulsion, basically like it must be some kind of force. That also means that these charges exert force. Yes, exactly. This was explained by Coulomb, by Coulomb's law, which we know, which we will discuss at a later stage. I am also thinking to make a series of videos on this electrostatics, which I am just considering. I am trying to learn better. So before that, like I just want to show certain activities to you for you to probably enjoy electrostatics. Getting back here, we know there are two kinds of charges. One is positive, another one is negative. And for a positive charge, the field is radially outwards, and for a negative charge, this radially inwards. Like there are so much in detail, and you also would be fascinated like what makes charges flow. Like you know that conductors would allow flow of charges while insulators do not. Now, when we come to insulators, we actually come across a very interesting phenomena, static electricity. Like when I rub, let's say like I have a pipe and I have a plug here, and I actually rub it. Basically, what's happening here is I'm providing energy through friction. That energy is taken by the electrons from the pipe, and these electrons will transfer to this flow, making this pipe negatively charged. How do I know this is negatively charged? Probably if I place it next to another insulator or something over here. Now when I see this, yeah, wow, that's interesting, right? Like it's experiencing force of attraction. What does that mean is there is something that is attracting it. That something is nothing but the negative charge over here. Like once more. Yeah, that's pretty good. Yeah. Getting back. Now what can we conclude is these charges can actually apply certain amount of force. Like to look at it in a lot more better way, I have a balloon over here. Now if you see, what I have here is the Van de Graaff generator. There is a little bit of air drag. Ignoring that. Now the moment I switch it on the Van de Graaff generator, it would actually come across a very interesting situation. Wow. You see that particular balloon getting attracted to, oh I'm sorry, I think there is a little bit of air. Now it is getting repelled as well. Just cut the video and yes, I am trying to, if you see here like this is a Van de Graaff generator and it is giving electrons over here. The excess electrons are on the top of this shiny aluminum shell. Now what I am trying to do is I am just putting those electrons onto this. Now what should happen? These electrons and these electrons must put force on one another, making that balloon to go away from it. Let's see what happens. Yeah, interesting. Now if you see that balloon is actually going away. If I move it closer, it goes further. But if I take my hand near to the balloon must attract my hand. You see that? Interesting. Yes. What can we effectively conclude here is these charges can apply force on one another. Now if I touch this, the balloon must come back. 1 second. There is a paused. You can clearly see the balloon getting repelled. But the moment I switch it off, there are electrons on this, there are electrons on that, both are repelling one another. How can I prove that? But if I touch this particular shell, the electrons are going to flow through me, making this neutral, while that is negatively charged. So that balloon has to move back to its initial state. Yes. And that's why heading from here on, one more activity what I have here is to show the same repulsion in a much better way. I have certain thermocoulant balls and I have a cup over here. If you see, this cup have a conductor, and the moment I place this on the Van de Graaff generator, this conductor will get charged and sending those charges onto those small balls, these thermocol balls. And once those small thermocol balls get charged, all of them are going to be negatively charged. Now they have to repel one another. So the moment I switch it on, based on our understanding, this should just fly away. Let's see if that happens. Yeah, let me place it out. We have here, and I'm ready. I'm really excited about it. Like 3, 2, 1, go. Oh, nice. That's cool science for you. Now continuing from here on, like one more activity what I have here is like Akash, could you switch off the lights? Another very interesting topic is about potential and potential difference, which students of class 10 they study, like that's where they begin. Now if I see the number of electrons here is more than the number of electrons over here, the moment I switch on the Van de Graaff generator, I'm sorry, when I switch on the Van de Graaff generator, here the number of electrons are going to be more, making this stay at a higher voltage, and the number of electrons are going to be less in my position. So there will be effective potential difference. Like we will understand what is this potential and all those things at a later stage. But getting back here, if I place a tube light, one end over there and another end if I touch it, the tube light must glow. Along with that, if I place this particular tester over here, if I place it like this is going to be in same potential surface, or equipotential surface. And if I rotate it like this, I'm basically increasing the distance between the equipotential surfaces. We'll understand this, what are these equipotential surfaces at a later stage. So when I keep it like this, the potential difference must be almost extremely less. When I rotate it this way, given the distance is increasing, there must be difference in the potential, making this to glow when I keep it like this and go off when I keep it like that. Could you please switch off that light too? Yes. Now you see, I kept the tester and I'm going to rotate it. I hope you can see that tester light glowing. But if I rotate it perpendicular to the ground here, it's not. But when I hide it this way, it's glowing. Not glowing. Glowing. Not glowing. Glowing. Not glowing. Glowing. Now, let's make this a lot more interesting. Now, what am I going to do is, I'm going to take this tube light and I'm going to place this tube light in the one end, and I'm going to place the other, I'm basically going to hold the other end. Like there will be potential difference between me and the Van de Graaff generator, effectively making me to experience certain amount of electric shock, which I'm ready for. Let's do it. Ready. I hope you can see that light tube light glowing. This is what's happening there. One end of the bulb is at higher potential, another end of the bulb is at lower potential. If there is potential difference across the terminals, charges would flow. If charges flows, whatever is the functionality of that device, it should work. And that's what exactly same thing is happening here. Now, the same thing would get a lot more interesting if I hold one end here and hold the Van de Graaff generator, and another person holds it from the other end and holds the other end. Let's see what is going to happen. Like then the potential difference at the Van de Graaff generator must be equal to the potential difference over here, and potential difference here must be equal to here. So both would be at same potential. If there is no potential difference, charges should not flow, making light not glow. Could you please switch on the lights for a second? No need. Yes. Vishwas, could you? Yes, are you ready for it? Yes, I am ready too.
Okay, sir.
Yes, I am ready. Hold it. Now, if you see, both of us are holding the Van de Graaff generator. What does that mean is the potential difference across the both ends of this tube light is 0. So charges doesn't flow. But things would change if he gets down. Could you please get down? Leave it and get down. Please get down. Yes. Now could you touch that? Once more. Once more, please. Yes. Just switch up the manufacturer. And yeah, these are few activities. We'll actually do some more videos on this. Thank you.